Hello, everybody. This is Mr. Hinnon. Welcome to the Hinstitute, in which we are going to talk about the second half of Chapter 2, still kinematics in one dimension, but now it's going to be vertical motion. So we're going to look at things moving vertically. And when we do that, one of the key things that we want to take into account is we want to make sure that we are looking at how things move, how things fall, stuff like that. So in the absence of air resistance, it is found that all bodies at the same location above the Earth fall vertically with the same acceleration. You saw two videos that brought that up, and they were trying to show that if you get rid of air resistance, everything falls the same. And that's one of the things in the Veritasium video on the misconceptions that threw people off, is they kept thinking of it as the force being the same, but it's not the force, it's the acceleration that's the same. And we're going to talk about this as free fall. In other words, we're free of air resistance. And the value is this 9.80 meters per second squared. Here in the United States, you might see, or an older physics book might use 32 feet per second squared, but we're going to keep it metric, so 9.80 meters per second squared. That is the acceleration of all freely falling objects. And so in the first video with Dr. Cox, you saw that if you can remove all the air, if I were to take like a rock and a piece of paper and drop them with air, they're not going to fall the same, because air resistance is going to slow this one down. It's going to go down to the ground, but air resistance doesn't affect this one, and it still smacks in the bottom. But without any air, if you evacuate all that air, these two both have, and actually they always have, the same acceleration on them. It's just a matter of whether this one has some air resistance that affects it, and this one doesn't have nearly as much air resistance. So we're going to use that to help us solve some problems. And one of the key things that we're going to change about our kinematics, so now that we're dealing with vertical, I like to use Y instead of X. X worked great for horizontal, but now we're vertical. And you don't have to worry about the acceleration. It's always going to be given to you. And since gravity is always going to act downward, the acceleration is going to be negative g. So the acceleration is negative g, or negative 9.8 meters per second squared. What I'm going to do is I'm just going to slap those right into the equations. So for example, I took my first equation, the fact that VF equals VI plus AT. In place of the A, I'm putting in minus G. So I notice I now have subtracting GT squared, or GT on here, or subtracting 1/2 GT squared, or subtracting 2GY. So you don't have to put in negative 9.8. You're putting in just 9.8 for the acceleration, or for G. G is just 9.8, but I've put in the negative. I made all these subtraction as opposed to addition. So let's try some problems with this. For example, let's say that you are sitting at the top of some building and you drop it from rest. So VI is going to be 0. Whoops. Didn't mean to go back. And we're going to look at how far it has fallen. So what is the displacement of it after 3 seconds? And what's the velocity of it after 3 seconds? So what we're really trying to find are 2 bits of information. We want to find VF and we want to find Y. We know our VI is 0 because it's going to start from rest, and our time is 3 seconds over here. So when I get ready to solve for these different quantities, move myself over the way, I need to just kind of plug some stuff in. Now notice that I put that A is minus G, but I'm not going to be putting negative 9.8. So just kind of watch me. Let's start out by finding Y. Let's figure out this one. And I think the best equation for this is to use the Y equals VIT minus 1/2 GT squared. The reason why I like that one is because it's got our VI and our T in there that we should be able to solve for pretty easily. But plug in that it's 0 multiplied by 3 seconds, but that whole thing is just going to be 0 minus 1/2. G is just 9.8 meters per second squared, and then my time is 3, and that is squared. So to solve for this, My y, one of the things you're going to notice is that it's 0 minus this. It's actually going to be a negative answer. So I pull out my handy dandy calculator here and I plug in. I'm going to take 1/2 times 9.8 times 3 squared, which is 9. And I get 44.1 meters. So 0 minus 44.1 meters means that my y here is negative 44.1 meters. Why is it negative? Because it's going down. So remember, anything that we do, if it's upward, we're going to make it positive. And if it's downward, we're going to make it negative. It's a common thing that we do with vertical motion. And it's very important whether you're talking about going up or coming down when we find this. VF, how would I solve for VF? I think the best equation is that VF equals my VI minus G times T. So I would take my 0 minus 9.8 times 3. And so if I just take 9.8 times 3, that's going to be 0 minus 29.4. My VF would be a negative 29.4 meters per second. Why is it negative? Because this object is moving downward. So it's important as we do this, we want that negative sign in there so you can get that. Both of these answers are negative. You will be amazed at how much the acceleration of gravity can really affect things as we're talking about falling objects. Let's keep going. Let's try another little sample problem. Let's say that I have a coin here that's going to be flipped up in the air. So we're going to flip this coin up in the air, up in the air, and then come back down. And it wants us to figure out how high does it go. So we're going to try to figure out what y is. Oops. Try to find y. Now, with this, I know the initial speed is 5 meters per second up. So this initial velocity should be a positive 5 meters per second. But when I try to solve for this, I know the acceleration is negative 9.8 meters per second squared. I don't have to worry about that, but I don't seem to have enough information. To solve any of my equations, I need at least 3 bits information to find that fourth. So how am I going to find this? Well, if I take some object, I'm going to use this paperclip, for example, and I were to fling this paperclip up in the air, as it goes up in the air, eventually it gets as high as it possibly can. How fast do you think it's going when it's as high as it possibly can go? Well, if it still had some positive velocity, it would still be moving up. If it had some negative velocity, it would start to be moving down. So if you're going to go from positive numbers to negative numbers, there has to be a point where you suddenly go from positive to negative. You must have a value of 0. And that's going to happen when you're at the highest point. So when you're at the very top, we know that the velocity is always going to be 0 meters per second up here at the top. So that's very important as we get ready to solve this. So I can plug in lots of numbers. I know the acceleration, they didn't give it to me in the problem. I know the final velocity, they didn't give it to me in the problem, but they describe it. And I know the initial velocity. And I'm trying to find y. Now, I don't actually need t, but I could solve for t if I want to. The reason why I like this one to try to find y is one of my other equations is this one. It says that vf squared equals vi squared minus 2gy. If I want to solve it for y, really what I'm going to end up doing is bring this, I'm going to subtract this over to the other side, and I'm going to divide by this. So I would have VF squared minus VI squared over minus 2G. Now if I want to, I could kind of switch that around, and I could write this as VI squared minus VF squared over 2G. It's just a matter of how you kind of do it. Remember, G is just the 9.8. This has a negative, that has a negative. This is just G, so I'm just putting that in there. So as I get ready to solve this, I would actually be taking my 5 squared minus 0 squared over the quantity of 2 times 9.8. I need to do that bottom first. So I'm going to take 2 times 9.8 to get 19.6. Take my 5 squared, that's 25. So 25 over 19.6 should give me what y is. In other words, how high this coin is going to go. Handy dandy calculator, 25 divided by 19.6. And I get 1.2755. Really, I've got about 2 sig figs here, so I'm going to say this is positive. Notice I get a positive answer, positive right there, and it's going to be 1.3 meters above. So if I flick this thing, it's going to go 1.3 meters up, 1.3 meters down, and we're good. So great little examples of how we can use the idea of falling objects to figure out all this stuff. So when I actually have some object moving, there's different parts that are very important. At the top of the path, the coin is going to actually be moving, have a momentary velocity of 0. On the way down, it's going to have a negative velocity. On the way up, it's going to be positive. And we talk about the acceleration of it. Does the acceleration of the coin change? The acceleration is always the same. So this answer is no. Acceleration always equals minus g. So the acceleration always equals negative 9.8 meters per second squared. Gravity is always pulling down on the coin. That's the idea when we're dealing with that idea, that concept. Great little thing to finish with. So let's say you were standing on the edge of this cliff and you were trying to think, let's see, if I could throw this rock, I can either throw it up at 30 meters per second, or I could throw it down at 30 meters per second. I wonder which case would it hit the ground with the greatest speed. If I throw it up, as in part A, or if I throw it down, as in part B. Well, here's the key idea. If I throw this up at 30 meters per second, whoops, if I throw this up at 30 meters per second, as it travels up, this coin or this rock or this pellet, I guess they refer to it as a pellet, is going to be slowing down because gravity is going to be acting downward on it. So eventually it's going to get to a velocity of 0. It's going to be going 0 up here at the top. And then it's going to start coming back down. As it comes back down, gravity is now still acting on it downward. So everywhere, gravity always acts on it downward. But here it's going to speed it up. Here's the cool part. Since gravity is the only thing that's slowed it down on the way up, and the only thing that's going to speed it up on the way down, when it gets to the same level that you had before, it would be moving down at 30 meters per second. It would just be downward, so it'd be a negative if I want to think of it that way. Well, isn't that what we did over here in B? We threw it down at 30 meters per second. So if you throw it up, won't it be going down at 30 meters per second when it comes by? Now, again, this is assuming free fall. So we're assuming no air resistance on this thing. And that's not always going to be the case when you actually solve problems. So because of that, it doesn't matter if you throw it up or you throw it down, they would have the same speed and they would hit the ground going the same speed if you ignore air resistance. Now, A would take longer because it had to go up and come back down before going, but in terms of the speed or the velocity it hits the ground, it would be exactly the same. That's a whole bunch of stuff on freely falling objects on our vertical kinematics. We'll work some more on some problems with that. I hope you enjoyed this edition of the Hinstitute.